Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Deviation, Dispersion and Spectrum. This is part A of the main chapter Spectrum. So here we are going to solve the theory question. So my suggestion is before watching this video, watch the concept video. In the concept video you will understand how everything works. Here we are going to apply it based on the question. So first was the concept video, then come back to this video. So without wasting any time, we'll start with our first question. Most of the basics which we have learnt in refraction at a plane surface are going to be useful here also. So see the first question. How does the speed of light in a glass change in increasing the wavelength of light? We know wavelength and speed, okay, both are directly proportional. So they are asking if the wavelength is increased, what happens to the speed of light? Both are directly proportional. So if the wavelength increases, speed also increases. Our next question, which color of white light travels fastest and slowest in glass? See, the main thing about this question is not which is fastest or slowest, it is about medium. If it is in vacuum, all the colors will travel with the same speed. Keep this in mind. If it is in vacuum, in any other medium, based on the wavelength, more the wavelength, more will be the speed, correct? So only in vacuum, okay, all the colors of light will travel with the same speed, okay. Then now we'll go for this question. Now they are mentioned clearly it is in glass. Except vacuum, in any other medium, glass, water, prism, anything. So based on what we are saying, which is fastest and which is slowest, based on wavelength. More the wavelength, more will be the speed. In the previous question we have learned, correct? So which color has maximum wavelength? Red. So red color has maximum wavelength, so it will be fastest. Okay, Vibgayar. In a Vibgayar order, violet has minimum wavelength, correct? Violet has minimum wavelength, so it will be slowest. So whether it is going to travel fast or slow completely depends upon the wavelength. Red has maximum wavelength, that is why it is fastest. Violet has minimum wavelength, that is why it is slowest. But in vacuum, all the colors, okay, not only this one, all the radiations, in the next chapter we are going to learn, okay, all the radiations will travel with the same speed in vacuum. Keep this in mind. When it comes to vacuum, everything will move in a same speed. Our next question, name the subjective property of light related to its wavelength. See, first we need to understand what is this subjective property. See, subjective property means it differs from person to person. Okay, say I'll give you one example. Color. You take an example of color. Okay, a few people are color blindness, correct? So for me it is a different color, for them it is a different color, and even though they are not color blindness, for me it may be black, for you it may be different color. Okay, so the property which differs from person to person. Okay, many people cannot distinguish the colors. For us it may be black, for them it may be silver, it appears to be silver. So what is the conclusion? Color is different for different person, so it is a subjective nature. So more about subjective and objective nature we are going to learn in sound chapter also. So here when it comes to light, what is the subjective property? It is color. Our next question, what is the range of wavelength of spectrum of white light in angstrom and nanometer? See, when it comes to remembering the values, you don't have to remember any value. Okay, this is out of the syllabus. Our next question, name 4 colors of the spectrum of white light which have wavelength longer than blue light. Wavelength longer than blue light. So first for these kind of questions we need to write the Vibgayar concept. See, Vibgayar, you go in ulta way, okay, from the bottom. This is Vibgayar. What they are talking about, name the 4 colors of spectrum of white light which have more wavelength longer than blue light. See, wavelength, this is the increasing order. correct. Violet has minimum wavelength, okay, red has maximum wavelength. So this is the increasing order. So what they are telling, after blue light, okay, after blue light, which are the four colors have maximum wavelength, okay, more wavelength than blue light. See, we know this is minimum, this is maximum, so it is increasing. After blue, what are the colors we have? Green, yellow, orange, red. These are the colors have wavelength more than blue color light. This is how you have to tackle it. Whenever it comes to wavelength and about different colors, you write this order. Okay, Vibgayar, you have to start from the bottom to top. So why it is important? Because violet has minimum wavelength, red has maximum wavelength. See, in this question they are talking about blue color. Next, in the exam they may talk about yellow color. Okay, write the two colors which have more wavelength than yellow, that is nothing but orange and red. Write the three colors which have more wavelength than green color, okay, that is yellow, orange, red. So for that any question, okay, you have to get this order properly. Our next question, which color of the white light is deviated by a prism, okay, glass prism, the most and the least? See, this is one important question. See, this is, assume this is a prism. When a white light, okay, when a white light is entered, okay, it is going to divide the, okay, into 7 colors. Okay, don't worry about the number of lines. So here it comes like this, again it gets refracted. See, here we are going to get violet and this will be red, okay, this will be red and this is violet. So here when it comes to this one, what is the question they are asking? Which color of white light? So this is white light deviated by a glass prism the most. Deviation means more change in angle, that is violet. See, it is coming from here, which has taken more turn, that is violet. Deviation means more turn, okay, a huge change in angle. This is the incident ray, this is the emergent ray, correct? Which has deviated most, that is violet. Deviation means more turn, okay, more change in angle. This is the incident angle, this is the emergent angle. See, there is a huge difference, but when it comes to red it is not that much difference, but there is a difference. So which color has more deviation? Violet. Which color has less deviation? Red. That's it. So in this way you need to understand the concept, so you don't have to by heart things. Our next question, name the 3 factors on which the deviation produced by a prism depends, and state how does it depends on the factors stated by you. First we have to state the factors, okay, which affects the deviation. Then we have to tell them whether it is directly proportional or inversely proportional. State how does it depend, directly proportional or inversely proportional, or you can use it as if this increases that decreases. All those words you can use instead of using directly proportional or inversely proportional. But directly proportional and inversely proportional words are enough to explain everything. First we'll talk about the factors. See, they are asking for 3 factors. We'll learn all the 4 factors which is there in your syllabus. First one, angle of incidence. If the angle of incidence is increased, okay, the deviation first decreases. Okay, if you keep on increasing the angle of incidence, the deviation decreases, reaches the minimum value and it starts increasing. The second factor, okay, this is the only factor in which deviation first decreases and then increases. The remaining 3, it is directly, okay, whether it increases or decreases, fixed. Second one, material of the prism, that is nothing but the refractive index. See, if the refractive index is more, angle of deviation is also more. So these two are directly proportional. Refractive index and this one, deviation, are directly proportional. Then third one, see, we are not only stating it, we are stating how it is affecting also. Angle of prism. What is angle of prism? That is nothing but the value A, which we have learnt earlier, correct? So angle of the prism, see, this is the angle of prism. This angle is called angle of prism. So angle of prism is directly proportional to deviation. More the angle of prism, more will be the deviation. So that is nothing but angle of prism is directly proportional to deviation. Next, the color or wavelength of light. See, we know refractive index is directly proportional to deviation. Then definitely this one, wavelength is inversely proportional to deviation. Why? Because refractive index and wavelength are inversely proportional. So here, or else you can understand like this: wavelength or color, both are same. Okay, for now assume both are same. Angle of deviation increases with decrease in wavelength. This you should know. So angle of deviation and wavelength, these two are inversely proportional. Our next question: how does the deviation produced by a triangular prism depends upon the color of or wavelength of light incident on it? This question we have learnt in the previous question, correct? The wavelength was one of the factors how it affects the deviation. Here they are specifically asking how does it affect. See, these kind of questions you can expect. They will not, in the exam they will not ask you name 2 or 3 step factors. No, they will give you the factors. You have to tell them how it is affecting it. So how angle of deviation depends upon color or wavelength? It is inversely proportional. As the wavelength increases, deviation decreases. That's it. Our next question: write the appropriate wavelengths for blue and red light. That is nothing but they are asking for a value. I already told you that remembering the values and writing the values is not there in the syllabus. So you don't have to remember the wavelength and frequencies of any color. All these things will be mentioned in the question if they are asking any question related to these kind. Okay, so part A we are going to skip it because it is related to remembering the value, not required. Second one, the wavelength of violet and red color are 4000 Armstrong and 8000 Armstrong respectively. Which of the two has the higher frequency? See, keep one thing in mind. Wavelength and frequencies are inversely proportional. Okay, so the color which has more wavelength, it will have less frequency. So what is their question? Which of the two has higher frequency? Out of blue and red color, okay, the wavelengths they have given. See, these kind of questions you can expect. The value they will give you, you don't have to remember. See here, violet and red color, 4000 Armstrong and 8000 Armstrong, these are the wavelengths. And how, which has the highest frequency? The color which has least wavelength, which will have the maximum frequency, because wavelength and frequencies are inversely proportional. So what is the answer for this question? That is violet, because violet has minimum wavelength, that is 4000 compared to red color. So it will have, definitely it will have higher frequency. Our next question: write the 7 prominent colors present in white light in order of increasing wavelength. See, this word is very much important. Increasing wavelength or decreasing wavelength. See, if they, okay, first I'll write the answer for this one, then you will understand what is the other way. Okay, if they change the question of decreasing wavelength. So increasing wavelength means first you have to write the color which has minimum wavelength. The last color should have the maximum wavelength, so that it is in increasing wavelength. Vibgayar. Okay, violet. See, this is the increasing order. Increasing order. Violet as minimum wavelength, red as maximum wavelength. Increasing order. If they change the same question, write the 7 prominent color present in the white light in order of decreasing wavelength, then you have to start from red. If you start from violet again, it will be completely wrong. Our next question: name the 7 prominent colors of white light in a spectrum in order of their increasing frequency. See, previous question was about increasing wavelength, correct? So we know wavelength and frequencies are inversely proportional. So which color? Increasing frequency means the first color which you are going to write, it should have minimum frequency. The last color which you are going to write for will be having maximum frequency. So red color has maximum wavelength. Red color has maximum wavelength, so it will have minimum frequency because these two are inversely proportional. See, 7 prominent colors, right? So red has maximum wavelength, but that is not the question. So the order has to be increasing in wavelength. Red has minimum frequency. Okay, this is about increasing frequency. Red has minimum frequency, violet has maximum frequency. See, these things you need to understand, but if you know only one, increasing order of wavelength, that is enough. So then if they ask a decreasing order of wavelength, you can write. If they ask increasing order of frequency, decreasing order of frequency, all those things you can answer. But for that you should have a little knowledge that frequency and wavelength are inversely proportional. Our next question: the wavelengths of the light of red and blue colors are nearly 7.8 into 10 power 7 and 4.8 into 10 power minus 7 respectively. See, the wavelengths are given. We know compared to blue and red, which has maximum wavelength, red. So we need to know red as maximum wavelength compared to blue, blue as minimum compared to red. This we should know. Okay, the same thing they have given in the form of values also. Now we'll go for the question. Which colors have as the greatest speed in vacuum? I already told you, in vacuum all the colors will travel in the same speed. So this question, which color? Both the colors. Both colors. This should be your answer. That's it. You don't have to write the full sentence. Both colors will have the same speed in vacuum, because they have the wavelengths doesn't matter in vacuum. All those reasons they are not asking, so don't write. Okay, so what is the answer? Which color? Write the color name. That's it. Next, you don't have to write it in sentence also, just the answer is enough. Which color has the greatest speed in glass? Now glass is a medium. Any medium, okay, it depends upon wavelength, but in vacuum it does not depends upon anything. So all the colors will travel in the same speed only in vacuum. So here, which color has the greatest speed in glass? Glass is a medium, right? So their wavelength comes into picture. So which color has maximum wavelength? Red. So red will travel faster in glass. That's it. This is how you are going to write it in the exam. This one also is not required. Only these two are enough, because these two are for 2 marks, 1 mark each question. Okay, you can get the answer within 10 seconds if you have a proper knowledge. Our next question: define the term dispersion of light. See, dispersion is nothing but splitting. This you should know. Okay, you should there are many words: deviation, dispersion, spectrum. All those things. What is the difference between all those things? We have learned in a correct concept video. Now here also, because of the question, we are going to learn. See, dispersion means you need to understand it is splitting of color. So dispersion is a process of splitting of a beam of white light. Whenever you give white light, it will split into different colors, 7 different colors. So it is a process of splitting of a beam of white light into 7 prominent colors. 7 prominent colors when it is passed through a transparent medium. So this is nothing but dispersion of light. Our next question: what do you understand by the term spectrum? See, dispersion is splitting. Okay, splitting. After splitting, we see different colors. No, this band of colors, different colors. Band means different colors. The complete band, we call it as spectrum. So how can we define it? On passing a white light through a prism, the band of colors seen on a screen, the band of colors means different colors. Okay, the different colors seen on the screen, this is called as spectrum. See, dispersion is splitting. After splitting, what if you see any different colors, that band of colors we call it as spectrum. Our next question: a ray of white light is passed through a glass prism and a spectrum is obtained. Whenever a ray of light is passed through a glass prism, a spectrum, okay, so different colors are obtained on a screen. Now we'll go according to the question. Name the 7 colors of the spectrum in order. We know what order they are talking about. They are talking about increasing order of wavelength. Okay, this is assumed. Okay, you have to understand this properly. Okay, if they not specify any increasing order of wavelength or decreasing order of wavelength, always go for increasing order of wavelength. So violet to red. Okay, like this you have to write increasing order of their wavelength. Next sub question: do the colors have same width in the spectrum? See, for this question, answer is no. Different colors will have different width. See, why we are not discussing the reason for it? See, reason for this question is not given in the textbook, and if you want to know the reason, there are many reasons. It depends upon wavelength, deviation, and the refractive index. so and color also. So all these things comes into picture. There is no one single reason for this question, that's why we are not discussing. So do the colors have the same width? Width means thickness, okay, in the spectrum after they disperse. Okay, after we got the 7 different colors from a white light, their question is, do the colors have same thickness? No. Okay, the answer is no. Reason, you don't have to worry about it because it has many reasons and that is not mentioned in the syllabus, so no need to worry about it. Next, which of the colors of the spectrum of white light deviates the most and the least? See, deviates the most deviation means, okay, taking turn, huge turn. See, white light is given like this. We discussed this question, I have already discussed. See, it goes like this, correct? So which color has taken huge turn? Violet, and this will be red. So deviation most is in violet and least is red. That's it. Our next question, explain the cause of dispersion of white light through a prism. See, the cause of dispersion, why there is a dispersion, splitting of white light, that is what they are asking. See, very simple answer is speed of light. Okay, there is a change in speed of light because of the wavelength, that is the cause of this dispersion. What is the answer? The cause of dispersion of white light is the change in speed of colors. Change in speed of colors. Our next question, explain briefly with the help of the diagram, label diagram, how does the white light get dispersed by a prism? Okay, that one we can aramse do. Now next questions are very much important. On which surface of the prism? On which surface of the prism? This is the first surface and this is the second surface. Okay, see, the light enters here, right? Enters here, so this is the first surface and this will be the second surface, that we should know. Now on which surface of the prism there is both dispersion and deviation? For this, to answer this question, you need to know the difference between dispersion and deviation. See, dispersion is splitting of colors. Okay, splitting of colors. Deviation means change in angle. So if I give, this is the angle I have given, if it goes in the same direction, there is no deviation. If it changes their direction, that is deviation. There is a deviation. So deviation is change in angle. Dispersion is splitting into colors. And keep one thing in mind, this we discussed in concept video also, prism will not produces color. Okay, in the prism the colors are getting dispersed, splitting. Okay, it is the prism is not producing the colors, it is splitting the colors. That is, splitting is nothing but dispersion. So on which surface, see, now see the question, on which surface of the prism there is both dispersion and deviation of light? So when the color enters here, the colors will start splitting. Splitting is nothing but dispersion, and there is a change in angle, right? See, this is the incident ray. Okay, now there is a change in angle. So on the first surface both dispersion and deviation takes place. Correct. This is what understanding means. See, dispersion is splitting of lights and deviation is change in angle. See, this is the incident ray and there is a change in angle. So there is both dispersion and deviation on the first surface. This is the first surface, where the light is entering, that will become the first surface. The second surface is nothing but the light is exiting. Okay, emergent ray. Next, then what is the next question? On which surface of the prism there is only deviation? So now, as the, see here, first surface we cannot say only deviation because we have, see, white light into split into different colors, so dispersion as well as deviation. Now we'll talk about the second surface. Here colors are not getting splitted. Okay, colors are not getting splitted, but there is a change in angle. There is a change in angle, so only deviation possible on the second surface. On the second surface only deviation red cannot split into different colors of red, correct? So if that is happening, then dispersion was also possible, but here the colors whatever it has dispersed, again they are getting deviated, change in angle. That's it. Our next question, the diagram shown below the path taken by a narrow beam of yellow monochromatic means single color. Okay, this is yellow and emergent ray is also yellow. Okay, passing through an equilateral prism, if the yellow light is replaced by a narrow beam of white light incident at the same angle, draw another diagram to show the passage of beam through the prism and label it to show the effect of prism on the white light. Very simple question. See, instead of yellow color light, what happens if I pass the white color light in the same angle? We know, we have learnt it, correct, in the concept video and many questions. So if you pass white light instead of yellow, it splits into 7 different colors. So on the first surface, both dispersion as well as deviation. On the second surface, again they'll take a turn, all the colors will take a turn, okay, towards the base. So that is again the deviation. The same thing, you know how to draw it, that's why we are not discussing it. Our next question, in the figure there is a white light, prism, and there is a screen. First, complete the diagram to show the effect of prism on the beam and to show what is seen on the screen. See, whenever white light is passed, 7 colors can be seen on the screen. So the part A is done. Now a slit. Okay, second question, a slit is placed between the prism and the screen to pass only the light of green color. What will you then observe on the screen? First we need to know what is slit. Okay, slit is nothing but it will be like this. Okay, it's a narrow gap. Okay, narrow gap will be there, so the light is going to pass. So what they are going to do, they are going to place this one between the prism and the screen, so that only green light will pass, only the green light will pass, the remaining colors will be stuck here, only the green light is going to pass. Okay, if green light is getting passed through the slit, what will you then observe on the screen? Green color only. See, what is slit? Slit is a material which has a narrow gap so that only one light can enter, correct? So if green light is entering, what color you will see on the screen? That will be green. Now we'll go for the last sub question. What conclusion do you draw from the observation in part B above? So in part B we can easily say green color is only passing, so we can see green color. So why you are telling like that? What is the conclusion? Very simple. Prism will not produce any color, it disperses. So that is the conclusion, that is the reason we can see only green color. Okay, prism will never produce any color. Our next question, a beam of monochromatic light undergoes minimum deviation through an equilateral prism. How does the beam passes through the prism with respect to its base? See, a monochromatic light, monochromatic means single color light is passed through a prism. So if it is undergoing minimum deviation, the important word here is minimum deviation, then what happens, how does it pass through the prism with respect to the base? If it is minimum deviation, the refracted ray inside the prism will be parallel to the base of the prism. If it is only minimum deviation, keep this in mind. So answer for this question will be parallel to the base. Second one, if white light is used in same way as a part above, what changes is expected in the emergent beam? So instead of monochromatic single color, if we pass white color, what happens? Okay, in the emergent beam, so it disperses into different colors. Okay, or else you can write a spectrum is seen, anything you can write, a spectrum, band of colors are seen, or there is a dispersion of white light, anything you can write. So if instead of monochromatic, if we pass white light, what happens? A spectrum is seen. Spectrum can be seen. Then part C, what conclusion do you draw about the nature of white light in part B? So what is the conclusion? We know because of white light we are getting 7 different colors. So white light is a polychromatic. White light is a polychromatic. You have to write it in the sentence. White light is a polychromatic in nature. So monochromatic means a color has only single color. Here polychromatic means one color. Okay, white has many different colors inside it. That's it. Now we have finished all the theory questions. Then we are remained with two numericals. That also we are going to learn in this video only. When it comes to numericals, only this formula is enough to solve both the questions. Now we'll go for the questions. First one, calculate the frequency. So frequency we need to calculate of yellow light of wavelength. Wavelength symbol is lambda, that is 550 nanometer. Then the speed of light, okay, is 3 into 10 power 8. Speed of light is nothing but velocity, that is nothing but 3 into 10 power 8 meter per second. So before going for the substitution, just check whether everything is in SI unit. So lambda unit is in meter, okay, it is nanometer. You can convert it here only. Nano is nothing but 10 power minus 9. All these things you should know. See, this is in meter and this is also in meter per second. We will get the frequency value in its SI unit, so that is proper now. So frequency is equal to V by lambda. What is V? 3 into 10 power 8. Lambda is 550 into 10 power minus 9. So first we send these prefixes that side, okay, to the numerator. So it becomes 3 by 550 into 10 power 17. When it goes to the numerator, it becomes plus. Okay, 10 power 8 into 10 power 9 becomes 10 power 17. That you know. Next, 3 divided by 550 will be 0.00545, okay, into 10 power 17. Now see, you can keep the answer like this also, or else you can move this decimal, okay, decimal point to the point after the first digit. See, it becomes 5.4. So 3 times it is moving, right? So 3 zeros we have to reduce. So what is the unit here? Here also it is hertz. Here, see, you can keep the answer in any way. Why I am showing you this way? Because this is mentioned in your textbook. Why they have to mention like this? Just they are moving the decimal point after the first digit, proper digit, 0. If you don't think about the 0, then first digit will be 5. So they are moving the decimal point to after the first digit. But if you keep it like this, you are going to get the full marks also. Our next question, the frequency range of visible light, okay, visible light is 3.75. So this is second question, frequency range. So first frequency is 3.75 into 10 power 14 hertz, and second frequency range, the maximum range is 7.5 into 10 power 14 hertz. And calculate the wavelength. We have to calculate the wavelength. Then speed of light, okay, with the speed of light is given, the velocity of light is given as 3 into 10 power 8 meter per second. See, very simple. We need to find the wavelength range. See, they have given the frequency range. Using these two frequency, first frequency and velocity, we will get one wavelength. Then second frequency and velocity, we will get the second wavelength. That is nothing but the range. First you have to write the minimum value. Second, okay, out of these two we are going to get two different wavelengths. Out of that, which is minimum, that we have to write first. Maximum, that is we have to write second. See, first one, using the first frequency, so we need to find lambda, right? So using first frequency, we are going to get first wavelength. Okay, we are going to get wavelength. Later on we are going to decide that will be the first wavelength or different wavelength, because based on the value. So assume lambda 1 only. How we can find lambda? To find lambda, we have to send this lambda here, frequency here. So lambda 1 will become velocity by f1. What is velocity? 3 into 10 power 8 divided by what is the frequency? Okay, 3.75 into 10 power 14. So now if you send this prefix that side, see, if you send this prefix to the numerator, this becomes minus, correct? 10 power 14 becomes 10 power minus 14. So 10 power 8 and 10 power minus 14 will become, so this becomes 3 by 3.75 into 10 power minus 6. 3 by 3.75, it is nothing but 0.8 into 10 power minus 6. Okay, this is the 1 lambda. Then second one, the same method using the second frequency. Lambda 2 is equal to V by F2. V is again 3 into 10 power 8 divided by, what is F2? 7.5. 7.5 into 10 power 14. Again this you can write it as 3 by 7.5, okay, into 10 power minus 6. So this becomes 0.4 into 10 power minus 6. What is the unit? What we are finding? Lambda. So that is nothing but meter. So here also meter. See, we out of these two wavelengths, so this is lambda 1 and this is lambda 2. So what is the range? See, the prefix 10 power minus 6, 10 power minus 6 same. So which is the lowest here? 0.4. So the wavelength range, the final range, okay, will be equal to 0.4 into 10 micro. You can write it as micro also. 10 power minus 6 is nothing but micro, right? Micrometer to 0.8 micrometer. That's it. Now we have completed both the theory as well as the numericals. So in this way you learn the part B and part C also. See, part A we are learning everything. Part B we are most of the topics are not there in the syllabus. So in both concept video as well as the theory solution, I'm going to teach you which concepts are not there. So focus on that mainly, because there are many things in part A, only few things are there in the syllabus. That's why knowing the syllabus is also important. Part A, part C, everything is important. Part B, you have to be very careful. All these videos, you know where it is. It is always in the description box. Thank you.